for this tree, delete assignments. We need to populate a binary search tree, so a BST, from an input file, which is input.txt, that contains a list of 2 numbers. The file can also contain the keyword delete followed by the number. And then if it contains delete and we have it in our BST, we are going to delete it from the BST. And if we're asked to delete something but it's not in our binary search tree, we are just going to add it in. And we have some more instructions about this right here. We also have a Google Docs that provides us 2 questions and answers. Now we are also going to use these definitions when we write out our actual code, when we print it. And we're not printing it to the console, we're printing it to a file. So we have to use a print stream where we have to change it to output and write it to an output file. And we are going to use pre-order, in order, and then we're going to print by list. So we're not going to do post order. So in here, we are just going to first make our new Java project. I made a new package, called it main, and then we're also going to make a new class, call it main, and surround it with public static void main string arguments. So our class is going to look like this. Now, we do be needing an input file. So what I'm going to do is open up this input file that I wrote where we have 1, 2, 3, delete 3, 5, 6, and 9. We're going to assume that we don't have any spaces after the actual numbers. And so what I'm going to do is I'm going to grab the input file, the text file from my other window, from my other monitor, and then I'm going to place it in the folder right here. Then I'm going to click copy to files, and then it should appear right here. So this is what our input.txt will look like. And if I go to the actual file explorer in my Eclipse workspace, I can go into the actual assignment itself, and we can see that the input text file is right here, copied as it should be. And when we're done writing this, hopefully we'll have an output.txt file as well that it will have written to. So in our main method, to set this up, we know we have to write out to a file. So we're going to do write to a file, and then inside of here we have to use the print stream, and then we can just call this anything. We'll call it console, and then we're going to set it equal to a new print stream where we are opening a new file, and we are sending this to output.txt. So what we have in here is the file name that's going to be created in our file explorer, manager, whatever, and that will hold all of our information. So we're going to have to hover over file, we're going to import file, we're going to also import the print stream, and so these will work correctly. And then from here we also need to add a throws declaration or a try catch. I usually do try catch, but I'll just do throws to keep it simple. So we're going to throw file not found exception. Now after we do this, we need to do a system.setOut, and what this does is it changes everything after it to go to our output.txt file, as long as we have console as the parameter in here. And then when we are done with all of this, you're going to need to close the console. So don't forget to do that. We're going to do console.close, and this will avoid any unwanted resource leakage. So from here, what we're going to want to do is pass the input file to the tree class, and we need to make our tree class. The tree class is going to have kind of a helper class, which is the node class. We need to make a node for our tree. Now normally a node, we have linked lists where it goes from left to right, but in a tree we have a root, we have parents and hierarchies and all that, but the main thing is we go left and right. So when we look at a tree, we have left and right leaves. So when we look at our node class, we're going to have to incorporate that. Our tree class is going to be called tree, and we'll just call it tree when we make an instance of it, and we're going to set it equal to a new tree. And inside of here, we know we need to read input.txt, so we're going to do input.txt. This is the file that we're going to read. We can hover over tree, and we're going to need to create the class. So we'll come down here. We know we need to make a node class first, so we'll do class node, and then that is going to be our node class. We'll fill it in a second, but we're also going to do class tree. And so that's the setup there. And finishing off our main method, because we're almost done setting it up, all we need to do is once we've done this, we've read this into our tree, we've inserted, we've deleted whatever this file asks us to do. All we need to do is print the tree to our output file. So we are going to do tree dot, and I will call this is what we're printing. I'll call it toString, and since it's already a toString method, I'll call it toString x. And so that is going to be the method there, and then we can create it down here when we are close to finishing. But that's the setup for the main class. That's the setup for the node and tree. Actually, that's not the setup for the node. We still need to fill this in. So the setup for the node, we have our initial kind of value. So it's going to be a type int for this project. We're going to do public int data. And then we have our left and right. So those will be nodes. We'll do public node left and public node right. We'll just do this on the same line. And then we're going to need a constructor for this. So we're going to do a public node. We are going to take some data as a parameter. We'll call it int data. And then inside of here, we're going to do this dot data is equal to data. And then we are going to do that our left is equal to null. And then also our right is equal to null. Because whenever we're inserting something, it's going to have null childs until we've substituted it with the data. So this is going to be the entire node class. We finished off our main class as well, and now we're going to get started with our tree class. In our tree class, we're going to need a constructor that will actually take this file name. So we're going to hover over and click create constructor. Before we even do that though, we need to keep track of the kind of head, if you want to think about it like a linked list, of our tree, but it's really the root. So this is acting like the head. We're going to have private node root, again though it is different because we're dealing with trees. So private node root is going to keep track of our root, and then we have public tree string, and then string here, which should actually be the file, which is our input.txt. So inside of here, we are going to have to read in that file. So we're going to use a scanner, we'll call it scan, and we're going to set it equal to a new scanner, where inside of here we have a new file where we are reading in our input.txt. We're going to need to hover and import scanner because we have not done that yet. And then we also need to have a parenthesis right here that I accidentally got rid of. We then need to also throw a files not found exception here, or surround it in a try catch. So that will now read in our file, and we want to examine every single line. So we are going to need to make a while loop, and this is going to go through the entire scan. So we'll do while, and then we'll have scan dot has next line. I'm sure you could do scan next. Either will work the same because there's only a number on each line. But we are going to store this entire line so we can examine it. We're going to do string line is equal to scan dot next line. So we get that in there, we store it in the string, and then we need to see if we need to delete it. So if we need to delete, we will be in an if statement, and then inside of our if statement, we're going to say, well, okay, well, let's look at the input file. If it starts with delete, we need to delete it. So if line dot starts with, and this is a string method predefined, a test if the string starts with a specific prefix. So if line dot starts with, and then we want to say delete, we are going to be in our if statement, and then we are going to say, well, we need to delete this. So we're going to make a method for it. We'll do string current is equal to line dot substring, and the substring we want to get is delete, and we'll have a space, and then we will do dot length. So inside of the string current, we are storing line.substring delete.length. This is going to get the length of it. And actually, yeah, we can't change it to an int because this substring is still a substring. So even though we're getting the length as a number, we are storing it as a string because of this substring right here. We can convert it to an integer though. And we're going to do this in our delete right here. We're going to pass in the current, but we're going to do integer dot parse int where we pass in current. And we could really just skip this step and put all of this inside of here, but I thought that was a little bit long, so I made its own method right here. We can click and create this delete method, I'm just going to change this to key so it's a little bit easier instead of having it as parse int. And now you might be a little bit worried if we look at our input.text and we don't have this number, like we don't have 9 in here, but it's still asking us to delete. We know we need to add in 9. Well, we'll make a method or something, a helper, that will take care of that. So if it does not start with delete, we are going to fall into an else statement and we would be inserting. So we're going to do root is equal to insert, and then inside of here we're going to pass in the root, and then we're going to pass in integer dot parse int, and then inside of here we're just going to pass in line, because line is just our scanned and it doesn't start with delete. We'll hover over insert, we'll click create method, and since the insert is being after delete, we're creating it afterwards. I'm just going to paste it down here. I'm going to change this to root, and then I'm going to change this to key as well. Now there won't be any naming conflicts because when we work in here, remember this root for the parameter has priority over this root. So there won't be any naming conflicts, but that could be some concern. We're going to need to do a lot for this delete. So what I'm going to do is separate it from the rest of the code just with comments. I'll paste this in here like this. And so this and also this will encapsulate our deletes. And actually this should go before the insert. And starting off our deletes, we need to first search our tree to see if it's even in here, because remember, if it's not, we're going to insert it. So we'll start off with an if. So we'll make a new method, we'll have to because we need to search our tree. If search root, we're going to pass in the root and we're going to pass in our key, does not equal to null, then we're going to delete it, right? Because that means it's something in here. We can hover over and click create method. It's made it a private and we have created it inside of here. Now we are going to have to change some of these parameters though, like this object. We're not going to return an object, we're going to return node. It is a search. We're going to change this to just root, and it's okay being as int key. And we're going to change all of this inside of here. Now let's go back to our delete. So if this happens, root is equal to, now we need to make an actual separate method where we're deleting. So we'll say deleting, and we're going to want to pass in the root, and then we're going to also want to pass in the actual key itself. So we'll hover over deleting, click create method. Now we want this under our search because it happens afterwards. So we'll paste it in here like this. We're going to change this to node, or I'm sorry, root, and all of this else looks good. And then we can delete this because we're going to need to write inside of it. So if it's not deleting, if it is null, that means it's not in there, and all we need to do is insert it. So we're just going to call the insert method. We're going to do insert, and then we're going to pass in the roots, and then we're also going to pass in our key. And that's it for this specific part of the delete. And now we need to search through our entire tree. For our search, we first can check 2 base cases, because we're going to need to make this recursive, where we recursively search the left and we recursively search the right. Our base case is going to be if our root is null, because if the root is null, that means it's not in here. And so if it's not in here, we'll break out of this if statement because it will be null, so this is not true, and we'll go into this else statement. So if the root is equal to null, or if our key is found, so if our root dot data is equal to the key, that means we're just going to return the root. And then if we return the root, well, we've either returned null or we've returned the key. Otherwise, we're going to go into this else if statement, and then we're going to say, well, we need to know how a tree works. So a tree, we have our root, and then we have the left, and then we have the right. More theory can be found in the playlist linked below the like button. But essentially, we have the lower values to the left, and then we have the higher values to the right. And so what that means is that in this else if statement, we need to see if our key is less than our root. Remember, this is the root. And well, if our key is, let's say it's less than our root, we are going to need to search the left side, right? Because the key is in the low area. So we'll say else if our key is less than root.data. We're going to be inside of here, and we are going to need to recursively search this. So we're going to return the search, and then inside of here we're returning root.left, because our new root will basically be whatever actual leaf or parent node is right here. Whatever node is the next one, that's what we're going to be looking at. So this will kind of act as a root. Remember, this isn't the actual root, it'll act as the root because we have more that we need to look at coming down here or coming down here. And so we're passing in root.left, and then we're also still passing in our key. Now we're going to have the same thing if our key is greater than root.data, or we can say if root.data is less than our key. If this happens, we are going to need to search the right side. However, there is an issue. If we hover over this, we need to add a return statement for this whole thing, because so far they're surrounded in cases. Well, this or this is the only other case that could happen. So it's safe to take out this if, and I'll just leave it as a comment right here so we can see what it's doing. And so that will complete our search. Now, if this returns and it's not null, we're going to need to hop into this deleting, where we actually go about deleting it. First is our base case. Remember, if the root is equal to null, we are just going to return the root. This is needed because we're doing it in recursive. Otherwise, we are going to say, well, else if our key is less than the root.data. Again, remember, we're going to have to be in the left side. So we're going to recursively go through deleting, and then we're going to pass in our root.left, and then we're going to pass in our key. And we're also going to do the same for the right side. So I'll paste this in here, else if, and then root.data, if it is less than our key is greater than the root, so we're going to have to look at the right side. So let's just say that we have our roots, we have two nodes, and then we have our value right here. Well, we're going to go through here, and we're going to say that this is the root, and our key is greater than. So we're going to be in our second else if statement. We're going to go down here. Okay, so that means the new root is going to be this. Now it's not the actual root, it's just going to be acting as the root in our code. And then we're going to pass this in as well as our key, and then we can see that our key is less than our root. So we're going to need to go this way. And remember, a tree has branches like this. So our key is less than, so it's going to be found right here. And then if this happens, we need to actually write an else statement for this, because we need to reorganize the tree. So we are going to have this else statement. We're going to be inside of here, and we're going to say, okay, if the root.left is equal to null, then we're just going to want to return the right. And then the same thing, we're going to say else if the root.right is equal to null, then we are just going to want to return, this should be right, this should be root.right. And then we're going to return root.left. So we're going to return the opposites. And then we have to actually rearrange this once we get the minimum value. When we find this value, this is finding it, and then we are going to recursively delete it once it's in the minimum spot. So we're not going to recursively delete it actually, we're just going to call the recursive one time to delete it, and it will delete it. It'll make sense when we code it out in a second. In the same else statement, but underneath all this, we are going to have root.data, and this is equal, you have to get the min value, so we'll do min value, and then we're going to pass in root.right. And then inside of here, we're going to hover over and we're going to create this method. So private int min value, and we're passing in node, and it's going to be right. We need to go through this and get the smallest thing. And remember, the smallest thing is always on the left-hand side. So at the beginning, we need to initialize our minimum value. So we'll initialize the min value to the root. Because if there's nothing in it, then our root is our min value. Or if there's one thing in it, our root's the min value. If there was nothing in it, we wouldn't be this far. I think it would stop a little bit earlier. It would stop right here. So assuming that there's at least one thing in here, because this would have caught it if not, we are going to do int min is equal to root dot data. So we're getting this, we're initializing at the root, and now we need to compare the entire left side. Because remember, looking at trees, the left side is the smallest side. It holds the smallest values. So we're going to have to do a while loop. And we're going to do while root.left does not equal to null. So as long as there's something, we are going to be inside of here. And we're going to reassign min. Min is equal to root.left.data. So we're going to get the left value here. And then we're going to reassign. Okay, so looking over this, this should actually be right.data. Because we're initializing min with our right.data. And we're going to compare it to the left side. So even though we have something at the far right, we know that it's not going to be the minimum because, like I said, everything to the left is the smallest. So even though we initialize it here, we're going to overwrite it if we have root.left. So minimum is going to be equal to root.left.data, and then we need to reassign root, and it's going to be equal to root.left. And this will eventually break us out of this while loop. We could probably do a for loop and just have this in the header, but this works just the same. Once we're done with this, we're simply going to return the minimum. And that is going to be it for the min value, and then we'll return it here. Now, remember I said that we're going to, after we do this, we're going to need to come back and we're going to delete. So we're going to do root.right, very right, is equal to, we're going to go to deleting, and we're going to do root.right, and then we're also going to do root.data. So those are the two things that we're going to be passing in. Our root.right is going to replace the node root, and then our root.data is just the key value, and that is going to be stored in root.right. So we go through deleting, we would do this, and then store it inside of here. Once we're done with that, we're just going to return our root, and that will complete our deleting method. And our minimum value will also be complete too. So just an overview of everything we've done so far. We've made a constructor, and this constructor is just reading the file in. Next, we have our delete method. So this is just going to check whether something should be deleted or inserted. If it needs to be deleted, we're going to come down into the search method. So we're going to pop in here. Actually, sorry, we're going to pop in here. And this is a helper for the delete. It's going to search through and see if our node does or does not exist. And then after we do that, we're going to need to actually go ahead and delete it, which is what this method is for. So we have our helper method for search that will delete a node and return what is left. Actually, it's not a helper method for search. It's a helper method for delete. And it will delete a node and return what's left. And then we also have our minimum value. We can't forget about that. It's a helper for the deleting method, which will get the minimum value. And that is how the deleting and rearranging of the BS tree, binary search tree, would work. Now we're going to move on to actually inserting. And that we have this right here. And then we're going to work on printing. So inserting was a little bit easier than deleting. All we're going to do is if the root is equal to null, all we're going to do is say, well, our root is going to be the new node where we pass in key, because there's nothing else in here. So our root is just going to be equal to our key, and then we could return the root. Otherwise, we're going to need to recursively go through this until we hit this base case. So we will have an else if statement, and we're going to say, well, if key is less than our root dot data, we need to go to the left hand side. So we're going to do root dot left is equal to a insert where we're passing in the root.left, and then we also pass in the key so we can examine both. Otherwise, we're going to go into an else if statement, and then we are going to say that, well, if our root.data is less than our key, we need to be in the right hand side, so we'll do root.right is equal to inserts where we're passing in root.right, if I can spell that correctly, and then we're going to pass in key. So that will be that else if. And then once we're done with all of this, we're going to eventually want to return the root. So we're going to unwind after we do our recursion. Remember, we would go through here and then we would go backwards. And so we would just return the root when we're done here. And that's it for the insertion method. Now we're going to look at printing. And it's kind of long like delete, so we'll just have this break right here. Inside of our printing, we are just going to have a method that will first print everything. This is what this is right here that we made in the main method. And now we can create the method right here. Scroll all the way down, and hopefully it did not print out what we wanted, but printed out right here instead. So we can just cut this, and then we will come down underneath our insert and paste it right here. So this is printing. We have a public void toString. And in our toString, we're going to have a sysout.println, where we say the tree in pre-order is this. Now we're going to need a method, and we'll call it pre-order because that's the name. It's super simple. And then we're going to do a sysout, and then we're going to say, well, we need the tree, and actually I'll do 2 breaks for lines, and we're going to do tree in order. And then we're going to need a method here. We're going to do in order, and then we're going to pass in the root. And then we're just going to do the same thing. Now we print. We are going to have 2 lines just for syntax, or for not syntax, but for nice output. And we're going to have tree by level, where we pass in the level. And then we want to have a level method, and we're going to pass in the root for this. And this is going to print out all the levels. We're going to hover over all these and create them. First thing that I want to do is hover over level because it creates them. The last you click is first. So we're going to create all of these. And then let's start with pre-order first. Now this isn't in the instructions, but it is known, and it is in some notes, that pre-order, we visit the root, we traverse the left tree, and then we traverse the right subtree. So I'll copy all of this, and then I'm going to paste it in the documentation that we will have right here. So we're going to visit the root, we're going to traverse the left subtree, and then traverse the right subtree. First, we obviously need to see if our root is null or not. So as long as our root is not equal to null, and this is really our base case, so we're going to be writing inside of our base case. And after we do our base case, we're going to unwind, and we're not going to do anything. So this is really tail, not, I forgot what the other one was, but basically we stop once we hit the end of recursion, and then when we're going back, we are not doing anything. So we're going to do a sysout.print, not print line, but just print, because we want to print these all in the same line. And the first thing I'm going to do is print the root.data. And then we are going to have a comma like this. And if we wanted to, we can make it a little bit fancier so that there's not a comma at the very last thing, but I'm just going to keep it simple and just visit the root. And then we need to traverse the left subtree. We're doing this in recursion. So we're going to do pre-order, where we pass in, and I'm going to change these root 2's just into root. Again, there's no naming conflict here because this takes precedence over our private root that we made earlier in this class. So since it takes precedence, we're going to do pre-order, and we're going to just pass in the root.left because, well, we need to traverse the left subtree. And then we're going to do the same thing but for the right. So pre-order, and then we're going to do root.right. Now we have our pre-order done. Let's look at in order. So in order, we need to traverse the left subtree, visit the root, and then traverse the right subtree. So it's going to be slightly different. In order, traversing the left subtree, we're going to call in order. This is going to be recursive. Oh, but make sure we need to do this in our if statement, our base case, if our root does not equal to null. We're going to be in here, and we're going to do in order. And then in our order, we're going to look through the left first. So we're going to do root.left. We're then going to visit the root. So we're going to do sysout.println, and then we're going to have our root.data. And then we're also going to need to append this. And then we're lastly going to visit the right. So we're going to do in order. And we're passing in root.right. So that is going to be that code. Now we need to print the level. Dealing with the level, we're going to need some helper methods for this, because what we're doing is we need to find the maximum depth of our tree, so kind of the lowest point, and then we are going to need to print each level until we reach that depth. So we are going to need to find our max depth in a helper method. And then we are going to print our actual level in another helper method. So we'll need two helper methods for this, and that will make more sense when we start coding it. So first we're going to store the actual depth in an integer. So we'll do int depth, and we'll say is equal to max depth, where we are going to pass in, and I don't want to say root for this, especially because we are looking at different levels. So I'm going to call this leaf, and I'll pass in leaf plus 1. And so we'll hover over this, and we're going to need to create our max depth method. Before we do this, let's continue a little bit on with our level. So we know we have multiple levels we need to look at, so we should use a for loop. We'll do for int level is equal to 1, and then we're going to run this as long as level is less than or equal to the actual depth, and then we're going to do level plus plus. We will be inside of our for loop. Now we need to print our level. So printing the level, we're just going to, like I said, make a method for it, and we are going to go through all of our levels. We could do it inside of here, but it might be easier again to just make it into a method. So in our method, we want to pass in our leaf that we are looking at, and then we need to pass in our level. And yeah, we'll just change this back to root, just to stay consistent with all the other times that we've called it root. I'm just looking at that, and I'd prefer it to be root. So now we can say, okay, well, we're going to print the level, and we're passing in our root, and we're going to pass in the actual level that we're at. So we have our root, we have our level. We're first going to print out the root, obviously, and then we're going to print out left to right, left to right, left to right, and so on and so forth until we get to the last level. And every time we run this for loop, because remember, we're just going to print out the first level, we're going to come back from this method, and we're going to go in the for loop again, and then go to the next level. We're going to want to make a new line, so we'll just do sysout.println to print a new line. We'll hover over print level, click create print level. We're going to cut this and paste it down here, and then I'll just get rid of this extra space right here. And so this is our level. Wrote out some Java documentation just to keep things neat, changing this to root. And now we can start with our max depth. Inside of our max depth, we are going to first need to see if our leaf is equal to null. And then if it is, we're going to return a -1. So if leaf is equal to null, we're going to return a -1. Now, this should be root. I remember I changed it from leaf to root. And then from here, we're just going to fall into an else statement because, well, if it doesn't equal to -1, then we are going to need to do some other stuff. And we're going to recursively go through this. We need to recursively see and add on to our depth. So what we're going to do is increment our left depth. But we need to do this recursively because we need to also kind of search through our tree. So we'll do int, we'll call it left depth, and we'll set this equal to max depth, where we passing in leaf dot, or not leaf, sorry, passing in root dot left. and that is the recursion for that. We're going to need the same thing for the right as well, so we'll do int right depth is equal to max depth, where we are passing in our root dot right. And once we do this, we need to see if our left depth or the right depth is greater. So if the left depth is greater than our right depth, we're going to be inside of here, and then we are going to return the left depth plus 1. Remember, we're returning an integer. So once we do all of this recursion, the left side, we're going to do all of the right recursion. And then we're going to basically add these together every time it hits the base. We're going to fall into this if statement. We're going to add 1, and then we're eventually going to see which is greater, and then we're going to return whichever that is. So we're going to return if our right, okay, well that was actually kind of a bad explanation. These if-else statements, this else statement is going to be like this in reverse, is basically to see if our left depth is greater than our right depth. We need to get the greatest one because, well, that's where our tree is longest, and that's what matters. So we'll say else, and remember this is if our left depth is less than our right depth. We are going to return the right depth plus 1 because it's greater. So that is the max depth in a nutshell. And now we are going to go to the print level. In our print level, we first need to see if our leaf is null, and if it's null, well, we're just not going to print anything. So we're going to do if leaf is equal to null. We will be inside of here, and we'll do a sysout.println, where we have these parentheses, or not parentheses, sorry, we have these quotes, and then we are just going to return. Keep thinking that it should be called leaf, when really we're calling it root. So we're returning actually we're just returning here, because it's void. Otherwise, so else if, we're in our first level, so if we're basically at the root, we're just going to want to print out the root. So we'll do else if level is equal to 1, that means we're at the first level. We're going to do a sysout.println, where we print out leaf dot, or not leaf, sorry, root dot data, and then we also have a comma. Otherwise, we're going to be in another else if statement that we're going to write, and this is for everything else. So else if the level is greater than 1, we're going to recursively go and print our levels. So we're going to say print level, and then we're going to pass in leaf dot left, not leaf, sorry. We're going to pass in root dot left, and then we're going to pass in the level, the current level, but we need to go down a level. So we're going to do level minus 1. And then from here, we're also going to do the right side, so print level, where we do root dot right, and then we do level minus 1. And that is going to be our else if. Something of note, we should make this just a print. We don't need it to be a print line, and same thing with this. We just print these because we want them on the same line. If it's in the same level, if it's in a different level, this print line is going to separate the levels. So that should be all of the code. We can go over it really quickly. Well, let's actually make sure it works first. So we finished our node, we finished our tree, finished all of our methods. Actually, I'll bring File Explorer over here so I can open it really quickly after it runs. We currently only have input. I'm going to run it and then bring back the file manager, and we can see we have an output text file. So we can open this, and the pre-order seemed to work. The in order, it looks like there is a spacing issue, so we'll go into the in order, and aha, we have a print line instead of a print. So we can update this by running it, just like that. And then I'm going to reopen our output text file, and we can see that we have tree, pre-order, and in order. Now the tree by level is all in different lines, and this is because, well, they are in different orders, or I'm sorry, they're in different levels. The order is the same, the level is different. Now, if we were to change our actual input to something like this, it would look a little bit different. So keep in mind, this is the output for our current right here. This is the output for when we have our input looking like this. That's the input, that is the output. Now, we're going to change our input to be like this. So we're going to run it again, bring back the file manager, and we'll click output.txt, and we can see it looks like this. So this was our first run when we had the different input, and this is our second. And yeah, it looks like it works, and it works well with the pre-order and in-order levels. And for more information on pre-order, in-order, or any of these tree methods, they will be in the playlist linked below the like button. But yeah, that is the code done, complete, and it looks good. So going over it, we have all of our imports. We have our main method, where we are having an output.txt in a console, so we're passing this all to a console. We're changing the print stream to set out to the console. Then we're going to pass in our input.txt to our tree class, and then we're going to print this. I'm sure instead of having tree.toStringX here, we actually don't need it there. And instead, what we could do is actually go into our method or constructor right here. And after it's done reading the file, so after it's done with this while loop, it'll automatically call the toString method. toStringX, this should be toStringX. So it'll automatically call toStringX instead of doing this. So let's delete this. Let's make some more abstraction. And I guess we wouldn't even need that, but let's see if this works. So we'll make this private, toStringX. We'll save it. We'll run it. Didn't get any errors. So I'm going to bring back up the file explorer, look at the output, and the output seems to be the same. Oh, but there is an issue. I don't know if it's with this, but we have an 8 in here when we should be deleting an 8. Our main method is good to look like this. This is great also because that means our thing can be private. We have so much abstraction, and we can add a suppress to our unused because we will be calling this. We will actually be calling our tree right here, and then it will print out, and then we will have to close our console. It will print to the console. So it looks like there might be something wrong with our delete. Okay, so I found the issue. It wasn't really that hard to spot. It was right here in our else if statements. So we did this right. We need to do this recursively. However, this deleting needs to be stored in our root.left, because if we just do this, well, we're basically just going over the same thing. We're not storing it inside of anything, so we're not updating anything. What we need to be updating here is our root.left. And for this next one, we need to be updating our root.right. So for these, we need to have our root.left and our root.right to be updated. And once these are updated, everything else should run fine. So let's try running it again. Remember, we want to delete 8 here. So I'm going to open this is the input, right? And let's open the output. We can see that we no longer have 8. So now the code works perfectly. Let's try changing it to something else. Let's try changing it, as a matter of fact, we'll try changing it back to our original input, which is this. So I'm going to go into our input file. I'm going to copy all this, paste it in here. So it'll look like this. We'll try running it again, opening up the file, output, it'll look like this. So I don't know if we had the same issue with 3 when we first ran this. We probably did. We most likely did. We had to have, because the delete was not actually deleting. It wasn't updating. The problem was we weren't updating our left and our right nodes. But now that these are updated, we've done the assignment, we've done the deleting, and we've done everything. So that is it for this assignment.